Good morning, students. Today, 23rd March, English medium, chapter 1, lecture 1, topic is electric field. See, there are three types of field: gravitational field, electric field, magnetic field. About gravitational field, you have already studied in 11. Okay, what is gravitational field? In this topic, we will study what is electric field. See, you know, if it is xy coordinate system, origin, one point charge q is placed at origin. It is a point P having position vector r at a distance r. If we place some charge at this point, that is q0, then according to Coulomb's law, on this q0 charge, force is acting due to q. Q exerts a force on q as per Coulomb's law. That is, Fr is equal to k q0q upon r square r caret. Where what is r caret? R caret is unit vector in the direction of force. If q and q0, they are like charges, you know that force acting on q0 is repulsive, means in this direction, okay, so r caret is unit vector in this direction. Clear? Coulomb, you already know. Question is, if from this point P, if I remove this charge q0, then what is left in surrounding? If your answer is no, then how this q0 charge exert force on q0 if there is nothing left in surrounding? Yes or no? See, if q0 is removed, what is left in the surrounding? If nothing, no effect is there in surrounding, then how force was acting on charge q0? Question mark. After numbers of experiments, scientists suggested that as due to mass, gravitational field is produced. Similarly, a charge produces some effect in the space around it. The region around the charge in which the effect of electric charge is prevailing is called the electric field of the charge. Yes, students, we have studied in 11 that due to mass, gravitational field is produced, and if there is another mass in that field, force is acting on it. Okay, similarly, see here, at origin, it is charge q. So this charge q produces some effect around it. This charge q produces some effect around it, and this region in which this effect is acting is called electric field. This electric field can interact with another charge q0 placed in it and exerts the force on it. See, understand here in figure. It is charge q0. This charge q produces some electric field. If this point P is in electric field and I place q0 charge here, then due to this charge q, force is acting on q0 because this q0 charge is in electric field of this charge q. Clear? Okay, to see how to find electric field due to any charge. See, the charge q0 used to define or measure electric field is called test charge. The charges producing electric field are called source charges. How? It is charge q. I placed q0 charge here, and if force is acting on this charge, means electric field is present. If I place here some charge, okay, suppose it is Q0 dash, force is not acting on it, means at this point there is no electric field. There is no electric field. Means to find, to measure, to detect electric field of this charge Q, we have used this charge Q0. That's why this Q0 charge is called test charge. It is called test charge. And this Q, which is producing electric field, it is called source charge. Now, what is definition of electric field? See, the force acting on a unit positive charge at a given point in an electric field of a charge of a system at charges is called electric field at that point. What is electric field? If you see equation, from equation you can easily write a statement. See, electric field is defined as force acting on unit positive charge. If Q0 is equal to 1 coulomb. If you take Q0 is equal to 1 coulomb. Okay, then see ER is equal to FR. Means you can say electric field is defined as force acting on unit positive charge. E is equal to F upon Q. E is equal to F upon Q, where here this Q is called test charge. See, from this equation you can easily define its unit. What is unit of force? Newton. What is unit of charge? Coulomb. It is Newton per coulomb. Or its another unit is volt per meter. That we will see in second chapter. See, force, vector quantity. Q0, scalar quantity. So electric field is also vector quantity. Electric field is vector quantity. Vector quantity means most important thing, direction. So what is direction of electric field? It is in the direction of force acting on unit positive charge at a given point. You have to remember this statement. How to find direction of electric field? It is in direction of force acting on unit positive charge at a given point. See, we will take two examples. Let it is positive charge. Due to this positive charge, you want to find direction of electric field at this point. Place unit positive charge. What is force acting on this point due to this charge? Like charges, repulsive force means away in this direction. Clear? If you want to find what is direction of electric field at this point, again place here unit positive charge. What is force acting on this point due to this charge? Due to like charges, repulsive force means in this direction. Clear? For negative charge, see, if it is negative charge and you want to find what is direction of electric field at this point, you have to place unit positive charge. Due to this negative charge, which type of force is acting on unit positive charge? Yes, attractive. And due to attractive force, the vector is towards. Clear? See, what is difference between positive charge and negative charge? Due to positive charge, electric field is radially outside. And due to negative charge, electric field is radially inside. It is radially inside. Okay, due to positive charge, electric field is radially outside. Due to negative charge, it is radially inside. Okay, it is direction of electric field for positive charge and for negative charge. Now, in this theory of electric field, you have to remember 2 points. First, Q0, test charge, used to find electric field. Value of Q0 tends to 0. Hello students, tends to 0 means near to 0, not 0. Near to 0, not 0. Why? Why? See, value of test charge. Value of test charge Q0 tends to 0. Q0 is used to find what is electric field. What is electric field? This Q is source charge. If we place Q0 charge at this point P, the location of this Q should not be changed. Should not be changed. That's why you have to take value of this test charge as small as possible. As small as possible. And what is its smallest value? Its smallest value is E. Its smallest value is E. Clear? Second point. Once electric field is defined, we can find force on any charge at that point with the help of equation F is equal to QE. With the help of equation F is equal to QE. Force is equal to charge into electric field. Force is equal to charge into electric field. Clear? So it is about electric field. Any charge produces electric field around it. If there are some charges within electric field, then force is acting on it. If charges are out of electric field, force is not acting on it. Clear? It is all about electric field. In next session, we will study electric field of point charge and system of point charges. Take a screenshot of this word, write down in your notebook. Knowledge student, you have to write this in your notebook and send me on my number. For other school students, write down, make notes and send to your respective subject teachers. Thank you.